All right. I hope your factoring is going good. We're going to keep factoring today. We're going to talk about some special factoring. If you recall, when we talked about multiplying polynomials, we talked about some special products. And so they're related to this special factoring. And we said if you had memorized those special products, it would help you when you got to factoring. So here's one of them, a perfect square trinomial. Okay, so two conditions must be true for a trinomial to be a perfect square trinomial. Okay, two of its terms must be perfect squares, and it's got to be the end terms. That's got to be something squared, and this has to be something squared. And then the middle term has to be 2 times each one's square root. So think about this. If I took the square root of x squared, that's x. And if I took the square root of 16, that's 4. So the middle term has to be 2 times x times 4, or in other words, 8x. So this is a perfect square trinomial. If those two conditions hold, then I can automatically factor this, right? And I know it's always going to factor as something all squared. You can write it twice if you want, but that's what makes it a perfect square trinomial. It's one thing all squared. And all I do is put the square root of this one here and the square root of this one here, and this sign will match right there. Another thing that has to be true is this has to be a plus. If there's a minus there, I don't care what these are, it won't work. So that has to be a plus. This can be a plus or a minus, and that sign will go right in there. Okay, so here's an example of that one they were just looking at. And you can kind of check it, because if you multiply it out, right, here's your x squared, and then you get 4 times x plus 4 times x. Remember, we had that double thing when we were multiplying them out. Okay, so there's the formula. If your first term, and it doesn't have to be just an x, right? I could have an x squared, z squared, but if everything over here is squared and everything over here is squared, then I look and see, is that middle term 2 times their square roots? Okay, this has to be a plus, but it factors like this. These signs coordinate. So let's try it. Okay, so this is something squared. It is x squared. This is something squared. It is 12 squared. That's a plus, so I'm good. Now my question is this middle term 2 times x times 12? Is that what it is? Oh yeah, 2 times 24x. If that holds, then I can write this using the x and the 12 all squared and this sign. Now notice this is a trinomial, so technically I could get by without knowing this rule too, because we just talked about how to factor trinomials, right? I could look for two numbers that multiply to give 144 and add to give negative 24. That one might not be too bad, 12 and 12. But look at this, I'd have to multiply, I'd have to find two numbers that multiply to give 225 and add to give negative 30. This is a really handy shortcut. It's really worth knowing. So anytime I have a trinomial now, I'm going to check to see if it's a perfect square trinomial. And it just takes a second, literally, because all I'm going to do is say, is this all something squared? Oh yeah, it's 5x, right? 25 is 5 times 5, that's x times x. And this is 3 times 3. If that's true, is this middle number 2 times this? Well, let's see. 2 times 5 times x times 3. Let's multiply it all out. 2 times 5 is 10 times 30x. Yes, that means it's a perfect square trinomial, and I know how it factors. I'm going to use this 5x and this 3 all squared with this sign. Boom. Okay, let's try it again. Okay, oh my, can you imagine figuring out two numbers that multiply to give 36 times 25? I'm hoping this is a perfect square trinomial. So, is this something all squared? Yes, it's 6a. Is this something all squared? Yes, it's 5. Is this middle term 2 times this times this? So is it 2 times 6a times 5? Let's see. It is not, right? 2 times 6 is 12 times 5 is 60. See, and I thought it was supposed to be. But it's real easy. It just took me a second to check that. Okay? So that means even though this really looks like a perfect square trinomial, it is not a perfect square trinomial, and I have to go over here to my previous method of factoring a trinomial. I'm going to look for two numbers that multiply to give. Remember what we did last time. I don't necessarily have to multiply that out. 36 times 25 and add to give 20. Okay, well, I've got 36 and 25, but when I add them, it's not 20. I don't know what it is, but it's not 20. So let's break that down a little bit. Let's make this maybe 6 times 6, and this one 5 times 5. And see if we can move it around a bit. Okay, so I could make this 30 times 30. But 30 plus 30 is not 20. Okay, that's about my only choices, so let's break it down some more. Let's change this 6 to 2 times 3 times 2 times 3 times 5 times 5. Whoops, 5 times 5. Okay, let's try this. Maybe, let's see. This is, let's do 10 times, okay, this would be 9 times 2 is 18 times, or 10 times 90. Oh, if I add those together, that's not 20, right? So let's do some other combination. Okay, let's do maybe 12 times 75. That's not going to be 20. Right? What are you thinking? Yeah, I don't see how I'm going to get combinations of these all multiplied out and only add to give 20, right? I might try a couple more, but these are pretty big numbers when I add them. 61, 60, 100, 87. I'm not anywhere near 20. Let's don't give up yet though. I need to make doubly sure. Let's think about this and see if we can get two. Just not gonna happen, is it? Okay, there's a 15, but this other number is going to be quite large. Okay, if I put the small numbers together, well, we're back to 36 and 25. No, I'm going to say that thing's prime. Make sure you basically exhaust all your possibilities, though, before you say it's prime. And just because these numbers on the ends are squares, it doesn't make it a perfect square trinomial. Okay, let's look at the next one. What is the first thing you notice about it? I hope you said it has a greatest common factor. Because if it didn't, this isn't even a square, it wouldn't factor, right? So I know they're at least all even, so I can factor at least a 2 out and an x. Remember, let's use our bracket. Okay, so that leaves 9x squared plus 42x plus 49. All right, and now I got to keep trying to factor this, but my question is, hey, is this a perfect square trinomial? Because I noticed that has a square root, 3x, the square root of 49 is 7. So is this middle term 2 times 3x times 7? 6 times 7, 42x, yes. Then I know how it factors. I've already got this factor, don't forget. I'm just factoring this. And so I know it's going to be this because it's a perfect square trinomial. And the first term is 3x. The last term is 7. And a plus sign in the middle. Okay. All right. So way handy shortcut there. All right. One more time. Is this a perfect square trinomial? Well, this is k squared. This is 10 squared. Is that middle term 2 times k times 10? 20k? Yes. So how does it factor? Okay, like this, where this is a k and this is a 10, and it uses this sign. All right, perfect square trinomials. Practice that. And then we're also going to talk about, okay, here's some information about factoring a perfect square trinomial, but we already know that. Okay, the sign of the second term is always the same as the sign in the middle term of the trinomial. The sign of the second term in the squared binomial. Oh, they worded that weird. Okay, the sign that you use after you're factoring it is the same as that sign between the first two terms. That's a better way of saying that. Okay, the first and last terms, okay, have to be positive. So this has to be a plus and that has to be a plus. Okay, and then this is the sign you use in your binomial. They can also be factored by grouping, but using the shortcut is a lot easier. Okay, so the other special product we're going to talk about today, remember if they were the same but they had different signs, we called those the difference of squares. That's because when we multiplied it out, it was this one squared and this one squared, always with a minus. So if I have the difference of two squares, it's a difference, that means minus, and something squared, I also know how to factor. It's the opposite of multiplying it out. So if you're going to factor something with two terms, a binomial, there's only 3 ways a binomial will factor. Well, other than, don't forget, greatest common factor, right? That goes without saying. That's your first step always, greatest common factor. But then, if your polynomial is a binomial, there's only 3 ways it'll factor. And that's if everything in your binomial is either a square or they're all cubes. Now the sum of squares, if this had a plus, it doesn't factor. It's not on the list. Sum of squares doesn't factor. Sum of squares doesn't factor. Guaranteed there will be at least one sum of squares on your test. It's not going to factor. Sum of squares does not factor. But if they're all cubes, it can be a plus or a minus. Plus or a minus. Okay, so this is how we factor by a perfect square, a difference of squares, sorry. This is how we factor the difference of squares, right? We take the square root of the first term, however many numbers and letters are here, the square root, put it here. The square root of the last one, put it here. Same thing for the second one, and then one gets a plus and one gets a minus. Doesn't matter which one. If we're doing cubes, we take the cube root and put it here, and the cube root and put it here. Now, this is the only time we wind up with not a binomial. And so maybe the 3 will help us remember, oh, one of them is going to have 3 terms. To get this second factor, once I do my cube roots, I square this one, so that would be an x squared. I multiply the 2 things together, multiply them together, and square that one, square that one. Same thing down here. Square that, multiply them together, square that. And then I figure out my signs by the word SOAP, S-O-A-P. Same, opposite, always positive. Same, opposite, always positive. All right, let's try that. Okay, factor each binomial. Well, assuming there's not a greatest common factor, the only way a binomial will factor is if they're all squares or all cubes. So here's my clue here. This is something squared. That's got to be something squared or it won't factor. Is it something squared? Now this is t squared. Oh, and this is 9 squared. So that means this factors as t plus 9, t minus 9. In this section, we just have to memorize these formulas, right? Just memorize these methods. Okay, it's a binomial. The only way it's going to factor is if everything is something squared or something cubed. So that's y squared up, not anything will multiply times itself and get 10. That's not a perfect square. It won't factor. Prime. I guess instead of boxing that, I should have said prime. Okay, so that's q squared and that's 6 squared, but if there's a plus on squares, it will not factor. The sum of squares does not factor. Don't fall into that trap. Pay attention to that. It's got to be a minus, right? At least 1 on the test, guaranteed. Okay, still trying to factor binomials. Oh, but this time I noticed this is a cube, and I want to know if this is something cubed. So one thing you can do, you can go over and make yourself a list of squares and cubes. Oh, sorry guys. Of squares and cubes, you know, so 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and you can go on and on and on. And then that way you have that as a reference. And look, yes, 216 is 6 cubed. They're going to expect you to know your cubes up to about 10 cubed, right? So 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1,000. So if you need that list there. Okay, so you won't have access to that list on a test, but you can make it for yourself. And if you're like, oh, I can't remember those, well, 7 times 7 is 49 times 7. You can come up with it pretty easy. 63, 28, plus 6, 34, right? So you should be able to come up with these numbers, and then you can use them. Oh, 216 is 6 cubed. So the cube root of this is x. The cube root of this is 6. That means that's what goes in my first factor. Once I have this one, I forget about the problem. And I square this, multiply it times itself. Then I multiply it times this. And then I multiply this times itself, or square it. SOAP. Same sign, opposite, always positive. When I'm factoring cubes, this is the only time I can be left with an exponent bigger than 1 in my factor that I don't have to keep trying to factor it. If this thing would factor any further, this wouldn't be how we told you cubes would factor. Okay, let's try it again. Okay, I know I'm looking for cubes. Okay, so is 27 on the list? Yes. So this is 3, and of course that's just an x. And is 8 on the list? Yes, that's a 2. So that's what goes in my first factor. And then my next one is this times this, 3x times 3x, 9x squared. This times this, 6x. This times this, 4. So same, opposite, always positive. I just have to memorize this, guys. Memorize it over and over and over until you have it memorized. Okay, still factoring binomials. Oh, but now I move back. It looks like I'm looking for squares. So is this something square? Yes. And of course this is. And is this? And is it a minus? Okay then. That means I just put that. This time I put that in each one. And one gets a plus and one gets a minus. Okay, don't forget to look for common factors first when you start having two numbers. Okay, another check for you is these better not have any common factors, or you gotta go back and take care of that and realize, oh, I missed a common factor. Okay, still looking at squares. So yes, that's 8 squared, and that's 9 squared. So all I do is put the 8a and the 9b in each factor. One gets a plus and one gets a minus. Doesn't matter which one. Okay. Oh, now I'm back to cubes. Okay, so is that something cubed? Okay, I know that's, of course, p cubed. And yes, that's 4 cubed. We've lost our list, but if you wrote it down somewhere, you'll see that's 4 cubed. So that goes in my first one. If it's cubes, I'm going to have a factor with 3 terms. And how I get it is square this one, multiply it times itself, then multiply it by this one, and then this one times itself. So, same, opposite, always positive. Okay, once again, I'm looking at cubes. So that I know is 3 cubed, and of course that's x cubed. That's 4 cubed, and that's y cubed. So that's what goes in my first factor. Okay, this times itself. This times this. And this times itself. So, same, opposite, always positive. All right. Now be careful. This isn't a perfect square, but it doesn't mean it's prime. There's a common factor. These are at least both even. So I can factor out a 2, and then that leaves 25 r squared minus 16. Okay, there's not another factor, but now I notice that this is 5 squared, and of course that's r squared, and that's 4 squared. And as long as it's a minus on squares, then I know how that factors. That 5r and that 4 go in each one. One gets a plus, one gets a minus. Okay, look at this next one. Okay, It's not a square, but any even exponent can be a square. Because think about this, z squared, let me put that over on the other side because I'm going to write there in a minute for a problem. So think about this, z squared squared is z to the fourth. So if I'm looking for the square root of this, it does have a square root. And this one has a 10. Likewise, z cubed squared is z to the sixth. So any even exponent you can write as a square. Any multiple of 3 exponent you can write as a cube. Okay, so that is something squared. This is something squared once we figure it out. That goes in each factor. One with a plus and one with a minus. Now, I have exponents bigger than 1 in my factors. I got to see if it'll keep factoring. The only time I don't have to see is if it was cubes, if I were factoring cubes, but this was squares. But this isn't anything square, so it won't continue. However, let's look at this next one. We already said that we could write that as z squared squared. So the square root of z to the fourth is z squared. Square root of 81 is 9. So I can write this as z squared plus 9, z squared minus 9. I've got exponents bigger than 1 in those factors, so I got to see if that thing will continue to factor. Now that's a plus, so it doesn't matter. It's prime, it won't factor any further. But this one, that's something squared, and that's something squared. So I'm not finished factoring this thing. This one doesn't factor any further. But this one can be written as z plus 3, z minus 3. Okay, soak that in for a minute. Okay. Come back to cubes, but don't forget common factor has to come first. And now the question is this something cubed? Yes. Is this something cubed? Yes. So it will continue to factor. That goes in my first factor, and then because it's cubes, this will be 3 terms. This times itself, this times this, and then this times itself. So, same, opposite, always positive. I don't have to check this one. It came from cubes. Okay, no common factors. And this is 4 cubed, right? And of course, that's x cubed. This is 5 cubed. And remember what we said about any multiple of 3. I could write that as y squared cubed. That's the same thing as y to the 6. So y to the 6 is something cubed. It's y squared cubed. All right. If I can get these numbers, that's what goes in my first factor. This times itself. This times this. And this times itself. So, same, opposite, always positive. Because it came from cubes, I don't have to mess with this or this one. It won't factor. Not that I don't have to mess with it, it's just that I know it won't factor. One more, and it looks like it's cubes also. So what do you think the cube root of 512 is? Right on, if you still have your list, it's an 8. What's the cube root of a to the 6th? Right, a squared. And the cube root of b cubed is b. So if they each have a cube root, that's what goes in the first factor. This times itself, this times this, and this times itself. Then soap. Same, opposite, always positive. Okay, awesome. Guys, this section is just, I just got to memorize those formulas, right? Just got to memorize it. All right, let me know how it's going for you.